Hello, and welcome to Lesson 2 in our second unit of Logic and Reasoning. Today we're going to be exploring parallel lines and what we can find as far as angle pairs, angle similarities when we're dealing with parallel lines cut by a transversal. And we're going to determine if lines are parallel based on a given angle pair. Okay, so we're going to look at the parallel line conjecture, and then we're going to look at the converse and see if that does work. We know based on the last lesson, sometimes the converse doesn't work. Okay, now, looking at our first setup here, a transversal is a line intersecting two or more other lines in a plane. Okay, so we've got the transversal cutting through here from top to bottom. And in this case, we have a set of parallel lines. Okay, parallel lines we always denote with a equal set of arrows. It can be one set of arrows, two set of arrows, three set of arrows to go through and do any of those pieces. Now, when we have a transversal, what we have is we have the interior section created by the lines in the transversal, and then we have the exterior sections as well. And notice, we have a lot of linear pairs, we have vertical pairs of angles, so there's a lot of things that we can pull in from the last lesson. We know that 2 and 3 are a vertical pair because their angle pairs make x's. We know that 1 and 4 are vertical pairs, the same thing down at the bottom. 5 and 8, 6 and 7 are all vertical pairs. And remember, we're using the less than 90, greater than 90 to help us set up all of those pieces, because we know that 1 and 2, we look at the angle 1, angle 2, they add up to 180 because they make a straight line with a linear pair. Same thing with 1 and 3, same thing with 2 and 4. Okay, so once we find a couple angles here, this whole picture really kind of fills in for us. So when we look at corresponding angles, okay, now we've got a set of parallel lines shown to us by the arrows here. And when we're talking about corresponding angles, let's look at the formal definition. Angles on the corresponding sides of parallel lines and on the same side of the transversal. Okay, now, that's a lot of mathematical speak right there. When we talk about corresponding angles, we want to talk about the same relative position. So we're looking at this picture, and we're looking at this picture. Corresponding angles are the angles that are in the same position. So 2 is the upper right angle, and that corresponds with 6, upper right angle. Now, if you notice, those are both over 180, and we'll find out soon that they're actually equal to each other. Okay, another corresponding pair would be 1 and 5. Okay, 1 and 5 are both upper left with respect to the two parallel lines and the transversal that cuts through. So when we're talking about corresponding angles, we're looking at the same relative position within the picture. 7 and 3 are corresponding, and then we've got 4 and 8 are corresponding. Same relative position within the picture of the parallel line that's being cut by the transversal. Okay, now, alternate interior angles. Okay, so we're looking at alternate and interior. So we know that the angles have to be on the interior of the parallel lines. Okay, so that's the interior. And then when we talk about the alternate, okay, alternate angles just means it has to be on the opposite side of the transversal. So alternate interior with 3 would be 6. Notice that they're both over 90 degrees, and they are actually equal to each other. Alternate interior with 4 is 5. Okay, they're both inside of the parallel lines. That's our interior, and they're on the alternate sides of the transversal. And the good news is their angle measures are equal to each other. Okay, and we can look at the formal definition here as well. 2 interior angles that lie on different parallel lines and on the opposite side of the transversal. Okay, now we get to alternate exterior angles. So once again, they have to be exterior, they have to be on the outside of the parallel lines, and they have to be on the opposite sides of the transversal. So the alternate is side to side from the transversal. The interior exterior has to deal with the parallel lines. So another alternate exterior pair are 2 and 7. And notice, both of those are greater than 90. The 1 and 8 are less than 90. We have a linear pair, so we know that those angles are equal to each other. Exterior angles that lie on different parallel lines and on opposite sides of the transversal. Okay, so now when we look at congruent angles, remember we're going back to our vertical pair, our x angles. So 2 and 3 are a vertical pair, 1 and 4 are a vertical pair. So we know that those are equal to each other. Okay, or congruent as we would call it. Okay, so we have congruent angles, equal measurements for 1 and 4. The same thing for angle 2 and 3. Okay, those are our greater than 90 angles in the vertical pairs. Okay, so we always want to remember that. We've got a vertical pair. We have a vertical pair of angles that are equal to each other. And then we also have our linear pairs. Going back to our first lesson, angle 1 and angle 2 are linear pairs, so we know that they add up to 180 degrees. Okay, now, if we have parallel lines, understand that parallel lines have the same slope, so that goes back to our very first lesson. So if they have the same slope, the transversal is one line. Now we know that these bottom angles are going to match up. 5 and 1 are corresponding. 5 and 6 are a linear pair. 5 and 7 are a linear pair. Okay, so we have a lot of pieces overall. Okay, so now, parallel lines conjecture. If 2 parallel lines are cut by a transversal, then their corresponding angles are congruent. Okay, which means that their measurements are equal to each other. Alternate interior angles are congruent. And alternate exterior angles are congruent. Okay, now, what about the converse? If 2 lines are cut by a transversal, form pairs of congruent corresponding angles, alternate interior angles are congruent, and alternate exterior angles are congruent, then the lines are parallel. Okay, so this is one of the times where the converse of the original statement is also true. Okay, now, last piece before we get started, I want to give you the picture. This is a picture of one of your homework problems. Okay, we're going through, we're filling in the pieces. The first thing that you have to do is identify parallel lines. So we have parallel lines here, we have parallel lines here, and we have parallel lines here. Okay, now, what we know is we're going to start using our pieces, but remember, within any individual picture, there can really only be two answers. There's the less than 90 answer and there's the greater than 90 answer, because we know that A and B are linear pairs, B and 64 are linear pairs, 64 and A are vertical angles. So you just have to work your way slowly through the picture, remembering the pieces that we have. We know about parallel lines cut by a transversal. There's only two options angle measure wise. If this is a 160, this has to be a 20. So this has to be a 20 and this has to be a 160. And if the lines are parallel, the next ones are just the same. Corresponding angles are equal, vertical angles are equal, linear pairs add up to 180 degrees. So we always have to keep those pieces in mind. And the one last thing that we also have to remember is any triangle that we can build. Okay, I can build a triangle right here. Okay, that triangle adds up to 180, the three angles. Okay, same thing with this triangle here. The three inside angles of this triangle add up to 180. Okay, so good luck on today's assignment. Let me know if you have any questions. Thanks and have a good day.